7 times, we would say that 7 and 10 are factors, and that 70 is the product. A prime number. A prime number is a number whose factors are only 1 in itself. Prime factorization. Prime factorization is breaking a number down to a product of primes. So let's consider the number 70 again. 7 is a prime factor because the only thing that makes 7 is 1 times 7. 10, however, is not prime because 10 can be broken down further into 2 times 5. If you're looking for prime factorization, the best method is to make a factor tree. A factor tree is where you take a number and you start breaking it down into factors. So 70 can be broken down into 7 times 10. 10 can be broken down into 2 times 5. And I look at this and I say, okay, I can't break down 7, and I can't break down 2, and I can't break down 5. So the prime factorization of 70 would be 2 times 5 times 7. We call this piece right here, we call this a factor tree. So, if I want to make, for example, what is the prime factorization of 60? Again, we're going to find the prime factorization of a number. A factor tree is a great way to go. So I take 60, I break it down, I look at 60 and I think, okay, that could be 15 times 4, that could be 30 times 2, that could be 60, or 6 times 10. There's a lot of ways I can break it down, and it really doesn't matter. We're going to end up with the same result. So let's say I go 15 times 4. I know that 15 is 5 times 3. I know that 4 is 2 times 2. So the prime factorization of 60 would be 2 times 2 times 3 times 5. If you chose to break it down differently, let's say you decided to break it down 6 times 10. This is 2 times 3, 2 times 5. We still end up with 2 2's, 1 3, and 1 5. So the prime factorization of 60 is 2 times 2 times 3 times 5. Even if you break it down 2 different ways, this will be your end result. Fractions. We've all seen fractions, we've all worked with fractions, we know what they are, but we're going to formalize this a little bit. Suppose I have the fraction 2/3. 2 is what we call the numerator. Three is what we would call the denominator. Now I could represent fractions in a number of different ways. If I look at this and I think of this as a piece of pie, 2/3 as a fraction would be 2 parts out of 3. So I I've broken this pie into 3 equal parts, 2/3 of that could be represented by shading exactly 2 pieces of this pie. 2/3, if I look at the rectangle, I could represent 2/3 by breaking this down into 3 equal parts. And shading 2 of these parts. Now the 2 in the fraction is really a count. It tells us how many we have. I have 2 pieces out of 3. The 3 refers to pies. How many pieces does it take to make a whole? How big are these pieces? Again, numerator refers to count. How many pieces do we have? Well, here I have 2 pieces. Denominator refers to size. Now when I say size, what I mean is how many parts does it take to make a whole? Well, a whole piece of, or a whole pie in this case would be 1, 2, 3 parts. The whole rectangle in this case is 1, 2, 3 parts. How to calculate area of a rectangle before. We use the formula area equals length times width. So let's suppose that I told you that this had a length of 2 and a width of 3. What would the area be? Well, the area would be 2 times 3, the area would be 6. Now if I break this down, this is 2, so let's suppose that this is 1, this is 2. Suppose I have this is 3. This is 1, 2, 3. If I was to draw a grid in here, I could see that if I have a 2 by 3 rectangle, maybe we're laying tiles 2 feet by 3 feet, I would have 1, 2, 3, 4, 5, 6 square foot tiles. And I think that's going to size us up pretty good for class on Friday. Thank you for taking time to look at this integrity video, and I'll see you all tomorrow. Have a great day.